Hello, my name is Cipher, and this is Blockhouse Defense Institute. So today we're going to be discussing Cipher, the techniques that we use to build it, our encryption and decryption algorithms, and our project management techniques that we use throughout this project. So I'll be starting by introducing the project and situating the research that we have done. So coming to the introduction, so cryptography has evolved from simple classical ciphers, for example the Caesar cipher and the Aptas, and it's come to modern computational ciphers, which are a lot more complex. So there's a clear trade-off here between accessibility and security. So the modern ciphers may not be as accessible, but they're definitely more secure. So the project addresses the well-known weaknesses of classical methods. So in our cipher, we've addressed different weaknesses of ciphers such as XOR, and we kind of made a hybrid cipher of Caesar and XOR to demonstrate how simple layering techniques can measurably improve resistance while remaining transparent, fast, and easy to analyze. So the system is explicitly designed for learning. So it should be. It's not something that can be used in the outside world, but it's very good for learning about ciphers and the different ways that they can be used.
Abdullah Farooq, I'm presenting literature review. Cryptography developed through trial, error, and major failure. We compared Caesar. There are 4 types of ciphers: Caesar, XOR, RSA, and AES. Caesar cipher fixed lettership with no real computational hardness. Only 25 keys, so brute force search is instant. Next is XOR. The same XOR steps encrypts and decrypts. So it is lightweight, no integrity. Attackers can flip bits without knowing the key. The next one is RSA, fast practical public key system, sold secret key sharing. Security depends on the difficulty of integer factorization. And last one is AES, 128-bit block ciphers with 10 to 14 rounds and 3 key sizes. It still needs DH and TLS for key exchange, and sidechain attacks can leak keys. Our cipher addresses these gaps through layered key transformation per session, entropy to stop, silent key reuse, no reliance on factorization or discrete locks, and built-in integrity without external key exchange.
David here, and I'm doing the software methodology. So this is a summary of how the project works at different stages. So the first stage is the iterative workflow. The project was running short iterative cycles, which meant the research, design, documentation, and presentation all improved together over time. The next stage is the product backlog. The backlog was built from analyzing Caesar, XOR, RSA, and AES, so both the strengths and weaknesses of each one directly shaped the design requirements. The next one is sprint planning. So the work was split across all of us into 10 of us, including cryptography research, algorithm design, report writing, and presentation preparation. The next stage is development sprints. Each sprint was used to improve the cipher logic, refine key scheduling choices, and strengthen the supporting documentation. The next stage, review and feedback. We done mentor meetings and presentation workshops at the regular checkpoints throughout the project. The last one is outcome. Scrum gave the team structure, accountability, and a clear way to improve work over time. This helped manage the group much better. This is, as you can see, the bad lifestyle summary and the tasks that we completed and how the workload reduced over time. You can see both the 2 tables. I'm going to pass over to my colleague now.
My name is Demilado Shioye, and I'm going to be talking about the product development. So we created an encryption system that joins Cipher, the Caesar cipher and XOR cipher techniques. It allows the user to input a message to encrypt or decrypt based on user-controlled parameters. So here you can see in the screenshots how I created the Caesar encrypt and decrypt functions and the XOR encrypt and decrypt functions, and then I ended up putting them together. So this shows that I created a user interface here. So depending on what you choose, you can either choose to have a Caesar cipher, XOR cipher, or them two together, and whatever choice you select will take you to the function that I've created. So these are all the selection menus for each of them over here. And then this is what it looks like when you put it in the terminal. So you'll start the script, you enter your message, you enter the shift value, then the key, you ask to encrypt or decrypt, and then that will be your encrypted message as the output.
Hi, my name is Dimitru Tanasie, and in this section I will present our system design. Our goal was to make it simple, clear, and effective. This slide shows how the system works. It starts with the user input. The system processes the data step by step. Each step changes the data until we get a final result. The reverse process works exactly in the same way, but backwards. This makes the system more reliable. The slide shows how the system is organized. We divide it into pods. Each part has its own role. This makes it easier to understand and manage. There is also an example showing how the system works step by step. This helps to prove that the logic is correct. This slide shows how the user interacts with the system. The user input the data, the system processes it, and it shows the result. It can also return the original data in the same format, confirming that the system works from the start to finish. Overall, our design is simple, clear, and works as expected.
Today, I'm going to present about ethical issues. So, first we consider dual use risk, that is social and ethical issue. While encryption shields authorized user, you can also hide illegal activity. Proportionality and explicit scope limitation are necessary for ethical design. Because of this transparency and the lack of production-grade security, our encryption is specifically educational, lowering the chance of misuse. That's according to Anderson 2020. So also we see CIA trade analysis, that is privacy versus security. So we see confidentiality, integrity, and availability. So in confidentiality, it promotes privacy and the GDPR's necessary technical protection. But overly, the measures may be obstruct legitimate access according to UK Investigatory Powers Act in 2016. So in integrity, tamper resistance is not guaranteed by our Cipher. So in availability, the deterministic, also its design prevents access loss brought on by intricate key management.
My name is Mario Raja and I'm talking about project management. So managing the teamwork. Project planning, we set goals, milestones and deadlines at the start of the project to guide overall progress. And the work was divided based on each team member's strength, ensuring everyone understood their role and responsibilities. Team meetings, we had regular meetings to review our progress that we've done, address any issues and stay aligned as a group. Notes were taken to record key decisions and outline the next steps, ensuring clarity and continuity. Keeping track of the work, we regularly updated, shared documents and tracked any changes that have been made. Communication, we use WhatsApp and Microsoft Teams for quick and efficient communication. More detailed discussions and decision making were carried through emails and online meetings. With the task management, tasks were allocated and managed using simple digital tools to track progress and deadlines. This helped us stay organized as a team and balance workloads and ensure the tasks were all completed on time. Staying on track, we continuously monitored our progress as a team against the project timeline. Any risks or delays were identified early and we worked together to resolve them and maintain a steady progress. This is an example, and this is just our meeting logs that we have completed.
Hi, my name is Halima.
My name is Majka.
And we will be reading the conclusion.
So to summarize, this project shows that combining standard encryption techniques like Cipher and XOR can result in a more effective and adaptable encryption system. It highlights the significance of combining security, usability, and performance, demonstrating that even simple approaches can benefit from integration and smart design.
Although the system is not designed for high security or critical application, it does give a solid foundation for understanding hybrid encryption concepts. With further improvements such as improved key management, increased attack resistance, and interrogation with modern cryptographic standards, the system might be made stronger and safe.
So the key points are: demonstrates a hybrid approach to encryption, improves security over standalone classical methods, maintain simplicity and user accessibility.
Useful as an educational and practical tool, can be expanded with more advanced security features.